Alright, so we're going to be doing some basic trigonometry. So for this, you're going to need SO, kata. So SO is sine, which is opposite over hypotenuse. Cos, which is the C, is adjacent over hypotenuse. And then the T for this one is tan, which is opposite over adjacent. First equation is going to be sine. How you find it is if we've got our angle here, 31 degrees. We've got x, which is opposite because it is opposite from the angle. Then we've got hypotenuse, which is 15. You know it's hypotenuse because 1 is the biggest angle there, and 2, it is opposite from the right angle. To work it out, you write sine, whatever the angle is. So for this one, 31. So sine 31 degrees equals opposite over hypotenuse. So opposite, x, over hypotenuse, which is 15. Because we just want x, we're going to times the denominator by itself to get rid of it. What you do on this side, you have to do on this side. So it is 15 times sine 31 degrees equals x, because we times this by 15, which cancels that out. To work out x, you grab your calculator. 15 times sine, which is this one, 31, close the bracket, equals 7.72, but we're going to just do the first decimal, which is 7.7, and that is your first one. Alright, for our second equation, we're going to be following ka, which is cos. For cos, there needs to be an adjacent. Adjacent is when it's between the angle and the right angle, as is adjacent. Then we also need hypotenuse, which again, as I said before, is the biggest angle, or another way to tell is if it's directly across from the right angle. So we need to write cos, write the angle, which is 31 degrees, equals adjacent over hypotenuse, which is x over 68. Again, we want to cancel out the 68. Do that, you times it by itself. And what you do on this side, you have to do on this side. So we'll be timesing this by 68, which is 68 times cos 31 degrees, which will equal x, because we cancelled those two. Our calculator, we go 68 times cos, which is the cos. They should all be next to each other, so it's quite easy. 31 degrees, close the bracket, which equals 58.28. Because 8 is higher than 5, this rounds it up to 58.3. So 58.3. Our last equation is toa, which is tan. To find this, you need opposite and adjacent. So let's look at our equation. So we've got our opposite, which if you forgot is always directly across from your angle. Our angle 31 degrees. Across from that is x. And then adjacent between the angle and the right angle. So if there's an angle and a right angle and there's a number between them, it's going to be adjacent. So for this, because it's tan, it is now tan. You write your angle, 31 degrees, equals opposite over adjacent, so opposite over adjacent. Now we want to get rid of the denominator, so whatever the denominator is, we'll times it by itself to get rid of it. What you do on this side, you have to do on this side. 28 times tan 31 degrees is equal to x, because we cancel these two out. So then we need to find x, because we need to do this equation, which we get our trusty calculator, and do 28 times tan, which is the last one if you've got a Casio, 31 degrees. Close the bracket, enter, 16.82. 2 is lower than 5, so because we're just doing one decimal point, it's just 8. If we write 16.8, and you're done. And that is how you can find each equation.
A planimeter is a mathematical tool that we use to measure the angle of elevation. I am now going to measure the distance from the door, which is 3 meters. Now I am going to measure the angle of elevation.
Now we're going to be drawing the diagram for our equation. First, we'll start off by drawing the door. And this is line A. This line that we drew before is the angle of elevation, meaning line is eyesight from her stance point to the top of the door. This is line of sight. This is the distance from the door to line A. These are the measurements we have from line A's line of sight to the bottom of the floor. These are the measurements that we need to find. So n will be our variable that we need to find, and x is the total height of the door.
Okay, so now that we have our diagram, we need to find the height of the door, which is x. However, before we can do that, we have to find n, which is from this point to the right angle of the triangle. To do this, we first need to find out whether we're going to be using sin, cos, or tan. To do this, we need to find out which line of the triangle is which. As we've been told before, the line with the right angle and the small angle is known as adjacent, so we're going to be putting a small a. And the line opposite the right angle is the hypotenuse, so we'll label with an H. And the last line left is the opposite, which we know as the line that's opposite from this angle. So we'll label it with a small o. So now we look at the lines we need. Since we've got our digit over here, which is 3, this will also be 3 meters. So we know that we'll be needing the adjacent. So we're going to tick the a above ka and the a above toa. And the opposite side is next to the variable n, so we know we'll be needing the opposite side. So we'll be ticking the o above so and the o above toa. Since toa has 2 ticks, we know we'll be using tan. Next, we draw our equation, which is going to be tan. We'll go tan of 29 degrees is equivalent to opposite of adjacent, so n over 3. We need to isolate n, so we'll multiply this side by 3. And what we do to one side, we must do to the other. So we'll go 3 times tan of 29 is equivalent to n. We know it's n because the multiplication of 3 crosses these two out. Next, we take out our calculator. So first we'll go 3 times tan of 29 degrees, close the bracket, and press enter. The answer is 1.66. But since we went to one decimal place, it'll be 1.7. Now that we have n, we need to find x. So all we need to do is go 1.52 meters plus 1.7 meters, which is equivalent to 3.22 meters. So x equals 3.22 meters. And that's how we calculate the height of the door from the distance and angle of elevation.